Hello everyone, my name is Priyatama Nambotla. Today I will be discussing critical vulnerabilities in web applications that relate to cookie abuse, specifically session hijacking via cross-site scripting and session fixation attacks. In our increasingly connected world, cookies play a central role in user authentication. They store a unique session identifier that tells the server who you are. If an attacker can access or manipulate this identifier, they can impersonate the user and gain unauthorized access to sensitive information. In our demonstration today, we will see two types of attacks that exploit this trust. One that uses XSS to steal session cookies, and another forces a victim to use attacker controlled session ID. While my colleague Prathamesh will cover Evercookies and private browsing issues later, my focus will be on the foundational concepts and defenses associated with abusing cookies. Let's start looking at XSS. XSS based session hijacking. In this attack, an adversary takes an advantage of unsanitized user input, say a comment field that directly outputs what the user types by injecting a malicious JavaScript code. For example, let's open the website. We have built a basic website that takes user inputs. So before logging in, we can just check the cookies. So this is the default generated cookie. So we'll give the credentials. Yeah. So we have generated another cookie now after logging in. So in the comment section, if we provide the script which is unsanitized, so we are actually stealing the cookie. And in additionally, we can send that cookie to the server of our attacker so that he can exploit victim. So yeah, we'll remove this and we'll post. Now, if we open the console, we can see that the current session cookie is being stolen and being stored here in the console. We can even transmit this to the attacker, this payload. So coming back, yeah, in our PHP code, if we force PHP to use the yeah, so this is called cross-site scripting. So moving on, now let's discuss session fixation. Unlike XSS, where the attacker steals a session cookie, session fixation is about forcing the user to use the session ID. Now we'll go back and we'll open a new session. So instead of providing uh, the captured or stolen session ID, we can force the user to take this session ID. Now we can check the cookies. So this is the cookie that we forced a victim to use. So if we give the credentials and move on to the next page, even the regenerated cookie is the same because we are forcing it. So this is being done because in our PHP code we use the session ID even before starting the session. And if the application doesn't regenerate the session ID upon login, the user will log in using the fixed session ID consequently. So moving on, as we have seen the both attacks, now we'll see how these attacks work and let's know the defenses and lessons we have learned. For cross-site scripting based session hijacking, the key defense is input sanitization and output encoding. For example, if PHP using functions like HTML special characters when outputting user data can prevent any embedded JavaScript from executing. In addition, implementing a strict content security policy can further restrict the types of scripts that are allowed to run on our pages. Regarding session fixation, the most effective countermeasure is to regenerate the session ID once the user authenticates using session regenerate ID. And also we can enable strict session mode. This helps reject the uninitialized session IDs, reducing the risk of accepting attacker supplied IDs. So yeah, one more thing is setting HTTP only flag on cookies, which prevents client-side scripts from accessing them, and using secure same-side cookie attributes that limit cookie transmission to other contexts. So in summary, these attacks teach us that cookies, while essential for user authentication, are also their weakest link if not properly secured. It's vital to combine the security coding practices with robust server-side checks to mitigate this vulnerability.
Hello everyone, my name is Prathamesh Dongrithot and today I'll demonstrate how Evercookies work and how they resist deletion, which is part of the second part of our project. And then as of part 3, we will evaluate how Google Chrome's private mode, also called Incognito mode, has its strengths, weaknesses, and how attackers might go around it. Let's start with part 2, Evercookies. Evercookies or super cookies is a type of cookie that is designed to be nearly impossible to delete. Unlike normal cookies, which are stored in a single place, Evercookies spread themselves across multiple storage mechanisms. It was created by a security researcher to demonstrate how websites can track users indefinitely. Wherever cookies are stored in multiple locations, they may be stored as an HTTP cookie. They might be stored in your local storage or in your session storage. It might be part of your indexed database. You might go into your cache or your retags, or they just might be part of a PNG or a WebRTC. Why are they dangerous? Ever cookies bypass user control, and even if cookies are deleted, they restore themselves. It enables persistent tracking across different websites even without user consent. It is used mainly by advertisers, but can also be used by malicious actors for tracking. Let's see an Evercookie in action. So I've set up an Evercookie here and I will run this. This runs our demo program where I can set an Evercookie. We've got an Evercookie set on this particular browser session. I can reload the page, and if I click get ever cookie, I've got the same cookie again. So now this happened because the ever cookie retrieved itself from my local storage. But how can we defend against these ever cookies? We can use we can start off by using privacy focused browsers. We could manually clear all storage mechanisms. We could disable JavaScript because it's required for ever cookies to function. We could use browser extensions to block tracking. And let's move into part three, which is Google Chrome's private browsing mode or incognito mode. Google Chrome's incognito mode is often advertised as a way to browse privately. Many users assume that it hides their activity from trackers, websites, and even Google itself. Now let's break it down. What does incognito mode actually do, and what does it not do? For starters, incognito mode in Google Chrome prevents history from being saved. They delete cookies and session storage after closing. They also block third-party cookies by default, and they run in a separate session that operates independently from normal browsing sessions. What are the limitations of Google Chrome's incognito mode? While it does provide some privacy, it's not a complete solution against tracking. For starters, it does not hide your IP address. It does not block fingerprinting. It does not prevent DNS tracking, and it does not protect against session-based tracking. An example of a limitation would be Google's incognito lawsuit from 2023, where they settled a lawsuit for $5 billion after it was revealed that even in incognito mode, user activity was still being tracked by Google services like analytics and ads. So how can attackers bypass this incognito mode? Some of the techniques that attackers use to track users in incognito mode are, one of them is browser fingerprinting, where websites collect unique characteristics of a user's browser, such as screen resolution, fonts, and plugins. Attackers could also use super cookies or ever cookies, like we discussed, and a combination of whatever storage mechanism that they want. They could also do IP address and DNS logging, because even in incognito mode, network operators and websites can track users via their IP addresses. So, how do we improve privacy in incognito mode? We can use anti-tracking tools. We could also use a VPN to mask our IP address and to encrypt our data. We could again book JavaScript based tracking scripts using browser extensions, and we could manually clear all browser storage after each session. Thank you.